Hello, Honors Geometry 2020-2021. Welcome to your first video of this school year. My name is Miss Fulton, your teacher, and we're going to get right into this curriculum. What you're going to notice about this curriculum is you're going to ask yourself, hey, this isn't geometry, this is algebra curriculum. That is correct. So to begin the school year, the district is asking us to cover some of the topics that you may have missed last year, which they deem as important and topics which have an impact later on in your education. So the main topic that we have to cover here in geometry is making sure you know polynomials, making sure you know how to factor, and how to solve quadratics with that factoring. Okay, I'm going to tell you, this unit is important because you're going to see it when you take Algebra 2 next year, and they expect you to remember this. But you're also going to see it this year in geometry. Throughout our units, I'm going to incorporate polynomials, factoring, solving with factoring, and so forth. So let's get right into it. And our topic for today is going to be this polynomial review. I would assume that probably all of you got to this before we left in March and went virtual, but if you didn't, it's okay. We're going to cover it today. If you get stuck, okay, pause, rewatch, ask me questions. I'm always here to help you no matter what. I'm here to push you to exceed, to do the best that you can. So the first thing that we're going to actually look into is some definitions. Really, what is a polynomial? What makes a polynomial different from something else? How do you know, looking at something, that I know this is a polynomial? First and foremost, a big thing is a polynomial is an expression. Okay, this is really important. Now, some of you may be looking saying, should I know what an expression is? Okay, it may be something you forgot. It's okay. We're going to take today and this unit and really focus on getting back those algebra skills, getting back those terminology that we're going to use it here the rest of the year. So first off, an expression, the main thing that tells you it's an expression it has no equal sign. Okay, when you were thinking back probably to the beginning of algebra, you had like 2x plus 2 equals 7, and you were asked to solve for x. That was an equation because it had the equal sign. Our expressions are going to be ones with no equal sign. If you go down here to our first few examples, these are expressions. Notice none of these equal something. There's no equal sign. Those are our expressions. So now if we go back here, okay, a polynomial just is not an expression. It has more to it. So to finish this out, okay, it's an expression or something that has no equal sign consisting of many terms. Now, first off, the main thing is what do we know is many? Okay, there's a couple things that we're going to define. Many can be anything from 0 up until infinity. Okay, when we get down here to this classifying polynomials, you're going to get a little bit confused when we get here. A monomial, a binomial, and a trinomial are just special type of polynomials. Okay, they're still a polynomial, they just have some special names. Okay, and we'll talk about that when we get down here to the bottom. Okay, now, terms. That can be something else that you forget back when you were in algebra. So let's look at it. Terms are numbers. They are variables. And then they could also be numbers and variables together. Okay, so now if we look at examples of both of these, numbers, maybe I look and say 3. There, that's a number. A variable, remember your variables are your letters. They're any letter of the alphabet can be considered a variable. And our most one that we see a lot, and you see it a lot also here in geometry, is x. X is our most common variable, but it could be y, it could be z, it could be a, it could be b. any letter of the alphabet is a variable. And now, our numbers and variables, this is another way of saying your coefficients with your variables. These look like maybe 3x or 4x squared. Okay, 3 and 4 being our numbers, or what we know is really coefficients, and then our variables being the x and the x squared. Okay, so a polynomial is numbers, variables, or numbers and variables, okay, that have no equal sign, but with one more thing. Something that makes this a term is if we have multiple, they are separated by a plus or a minus. So really, if we think of the big picture of a polynomial, it is a number, a variable, a number and a variable, okay, it could be any of those, that are separated by a plus or a minus and have no equal sign. So now, again, we see examples. Let's write out some examples. So, 4x squared plus 7. There is a polynomial. That's an example. Okay, this is a number and a variable and a number. It's separated by a plus or a minus. Now, simply just writing down a number, that's a polynomial. Okay, it's just one term there, but it's still a polynomial. Now, I could go large. I could say 4x cubed plus 7x squared plus 9x plus 22. There's another polynomial. Multiple separated, okay, by plus or minus. Now, do they all have to be plus? No, I just happen to, in those examples in my head, think of all pluses. I could throw in some minuses if I wanted to, and look, I'll throw in a minus. 3x minus 1. There's one that works. So now, when we have polynomials, the big thing how polynomials all have to be written is they have to be written in standard form. Okay, when we get down here to our examples here on actually number 1, we need to make sure that these are written in standard form. And when we talk about standard form, okay, there are two things that we have to take into consideration. Okay, the first thing that makes it in standard form is it's written from the highest exponent to the lowest exponent. So, if I have, for example, highest to lowest maybe is like x4, x to the 3, x squared, and x. Okay, that's from highest to lowest. Now, really the question becomes, what happens if there are multiple variables? Because remember, these exponents we talk about go with our variables or our letters. If you have multiple variables or multiple letters, okay, if there's multiple variables or multiple letters in your polynomial, in your expression, how we have to write it is we start with the variable that comes first in the ABCs. Okay, and we're going to see an example of that. Really, you're not going to probably run as much into that second one, so you aren't, as you are going to run into the first one, the highest exponent to the lowest. So, for example, if we look at highest exponent to the lowest, it could look something like this. Okay, 3a to the 4th plus 2a squared minus 4a plus 3. A is my variable. Notice I went from my highest exponent down to my smallest. Even though I don't have an exponent of a 3, I just skip over it. 4, and then my next highest was 2. Now, the one that gets confusing, like I said, is this second one. Start with a variable that comes first in the ABCs. So, I'm going to say for this one, I have both A and B. I'm going to put a little slash in there to separate those. Okay, so here on this second example I created, we have both variables A and B. A comes first in the ABC, so A is where I would have to start with. I went for my highest exponent of A's. Now, on this one it was interesting. After I got done with writing all my exponents of A's, I had something with an exponent that had just a B with it. That would go next. So after you go through your highest exponent of A's, if you have then a second variable, which was this case in B's, I start with that same idea. I go with my highest exponent that just had B's, write them out. The last thing you should always end with is your constant. Okay, this one we don't run so much. You're going to run into it in like Algebra 2 and so forth. Not so much here in Algebra 1 and Geometry do we see a lot of multiple variables. So now, we have our definitions. Let's get into a little bit further with polynomials. Next thing we have to do is how can we classify our polynomials? How can I know or call it a special name other than polynomials? And that's what classifying is. So we classify a polynomial, or we call it a special name, based on two different things. Okay, it's based on the degree and the number of terms. So degree is just fancy for saying highest exponent. Okay, so what is my highest exponent? That is what goes there for degree. Okay, now, then I look and I say my terms. We define terms up here at the beginning. Okay, we're looking for numbers, and variables separated by pluses or minus. How many of those do we have? That's our number of terms. Now, as we go throughout our examples, see if you notice a shortcut. Is there something that you notice that makes it easier to determine the number of terms? So here in our first example, we're going to classify the polynomial by degree, number of terms, make sure it's in standard form, and combine terms if needed. So our first example is 7x minus 11. So first off, when you are looking at the highest degree, you got to ask yourself, what are the different variables that you see in the problem? If I see multiple variables like A, B, C, D, X, Y, Z, how many ever I see of those, I'm going to look and say, which one of those variables has the highest exponent? Okay, so in this one, the only variable I see is X. So I'm going to ask myself, what is the highest exponent that I see with an X? And now, some of you may be looking and saying, well, there's nothing with the X. Remember, if there's no exponent, it really has an exponent of 1. So this makes it a degree of 1. Since 1 is my highest exponent, that means that this is linear. Now, some of you may be looking and saying, okay, I'm a little bit confused now because what happens, or what does it look like for a degree of 0? If you thought this was 0, your degree of zeros are just your numbers. 3 would be an example of a degree of 0, just a constant. Okay, so now we know that this is linear, the number of terms. How many numbers, variables, or numbers and variables are separated by a plus or minus? Well, 7x is one term, and it's separated by the 11 with a minus, so there's two things that are separated by a plus or minus, so 2 terms. And again, go up to the chart, 2 terms makes this a binomial. Okay, so now the last thing is standard form or combine like terms. Okay, well here on this one, this is an interesting and easy problem. First off, it's already in standard form because I went from the highest exponent with my variable down to none. And I can't combine anything because 7x minus 11 are different types of terms. So it stays 7x minus 11. Okay, let's look here at our last one here on this first page. Okay, so again, when you talk about degree, ask yourself, which different variables do you see? Because you're going to ask yourself, out of those different variables, which one had the highest exponent, that becomes your degree. So here on B, the only variable or letter I see is x. So now my question is going to be, what is the highest exponent I see on an x? And right here, 5x to the power of 4. 4 is my highest exponent. Under degree, 4 makes it a quartic. Okay, now, number of terms. Again, ask yourself, how many things are separated by pluses or minus? 1, 2, 3, 4. Those things are terms. So there's 1, 2, 3, 4 terms separated by pluses or minus. So I'm going to put a 4 here. 4 or more makes this a polynomial. Okay, don't get confused by what we wrote down as the definition and this polynomial. These are all polynomials. These are just special names for polynomials. Anything 4 or more, we just call it a polynomial because there's no special name. Okay, last thing, standard form combining terms. So now, on this one, what we run into is something interesting. We have it not in standard form. So if I want to put this in standard form, the variable with the highest exponent has to go first. So this 5x to the fourth has to go first. Since there's a plus in front of it, that makes it positive. And remember, to start out, we don't put a plus there to show it's positive. We let it alone. I don't have anything x to the power 3, but I do. So that has to go next. Power to 3. There's a minus with it, so I put a minus for x to the power 3. There's nothing to the power of 2. There is something to the power of 1. It's at 2x. Since there's nothing in front of it, it's a positive or a plus. And then you always end with your constant or the number by itself, minus 7. Okay, now, not so hard. Before we flip to the back, okay, I'm going to give you a second to think to yourself, do you notice something with the number of terms that makes it easier if you don't want to count? Okay, you've had a second to think. Let's see if you came up with what you could have noticed. Okay, some of you may have something different, and this is what I'm going to tell you. If you ever come up with anything other than what I tell you, but it still works, let us know. Like, let your classmates know, let me know. It's something that we can share out and we can use to learn from each other. Okay, learning from each other is going to be a big thing here this year. Helping each other out is so important in math. So now, what I've always noticed and what I always thought of when I saw like how many terms there were, I noticed a 2-term or a binomial only had 1 plus or minus. A 4-term, which in this case was a polynomial, had 1, 2, 3 pluses or minus. To get your number of terms, okay, if we wanted to give it a trick, this is 1 more than the number of plus and minuses. So if you have something that has, let's say, 3 plus or minuses, it's a 4-term. Okay, if you have something that has 2 plus or minuses, it's a 3-term. Your number of terms is always 1 more than how many plus or minuses there are in your expression or polynomial. Okay, let's go back here to the back. We have one more example under this one. Okay, so here on this one, okay, first off, degree. Ask yourself what different variables there are, because if you have multiple variables, you look at all of them and ask yourself which one had the highest exponent. On this one, we're only looking at x's. My highest exponent that I see on an x is a 6. So I'm going to put a 6 there. Okay, use your front to help you out. Oh, we run into a problem. There is no degree 6. Okay, that's because anything after this, there's no special name for it. So if it has a degree 5, we call it a 5. It has a degree 6, we would call it a degree 6. How you write that out here, anything 5 or more, you just do degree and then put the number that you found for it. So if it was 8, you call it degree 8. If it was 9, degree 9. There's just no special names for those. Okay, now, number of terms. We're going to do both ways so you can just see that it works. Okay, 1, 2, 3, 4, 5 pluses or minuses, so it means that there is 6 terms. Now, if you want to count everything except the pluses or minuses, we have 1, 2, 3, 4, 5, 6 terms. Either one works. Okay, if I go back to the front again, okay, I can look at it. 6 terms would fit in the 4 or more, so that makes this a polynomial again. You like to see that polynomials like to show up quite a bit. Okay, now, standard form and combined terms. Okay, we have some of both in this one. Starting with the highest exponent, we know it's 6 because this is a degree 6 polynomial. So, 1, 2 things have a exponent of a 6. We got to combine them. How I can combine them is your coefficients or your numbers in front, you add or subtract them based on what the signs are. You keep your variable and the exponent the same. So I have a positive 2 and a negative 4. That makes it a negative 2. Keep your variable and your exponent the same. So negative 2x to the 6. Okay, now you keep working backwards. Do you have anything x to the 5th? Nope. X to the 4th? Nope. X to the power of 3? Yes. I have a negative 3x to the 3. Since it's the only thing, I just write negative 3x to the power of 3. Now I go down, x to the power of 2, and I have 2 of them. I have a 8x squared. Since there's nothing there, remember I can always say it's a positive or a plus 8x squared. And I have a plus 3x squared at the end. So 8 plus 3 is 11, so positive 11x squared. Do I have anything with x's? No. And always your last thing should be just the number by itself. I have a plus 7. There I have written in standard form, and I have combined like terms. Okay, that gets us through just looking at polynomials. Now, once you talked about polynomials, you talked about how to kind of, I guess the word is manipulate, or how to work with those, okay, polynomials in a different way. Okay, and one of those ways is to look at distribution foiling, which is just another way of we're going to multiply with these. So now, let's talk about distribution first because that's the easier of the two. Remember, distribution occurs where you have something that is outside of the parentheses, okay, that we're going to have to take and multiply to every term inside of that parentheses. So here on A, I have a 3 outside. I'm going to take that 3 and I'm going to multiply it to every term inside the parentheses. So if we do that, first thing I run into is what is 3 times x squared? Well, that's 3x squared. Okay, then I have a 3 and a negative x. 3 times a negative x still stays negative. It's just a negative 3x. And then I can say I have a 3 times a positive 2. That is a positive 6. Now, once you have multiplied them through, you always want to make sure that they're written in standard form. So are we going from the highest exponent down to the lowest? Yes. Okay, and I can't combine anything because they're all different variables with different exponents. There's my final answer. Here on B, we have to do the same thing. But on this one, instead of taking the 3 inside, there is an x outside. So we have to take and multiply that x with everything inside of that parentheses. So x times x to the 5th. When you are multiplying variables or multiplying letters that are the same, you are adding exponents. So basically this is telling me I have 1x, because this would be x to the exponent of 1. And I have 5 x's here. How many total x's would that be? Well, that'd be 6. That makes it x to the 6th. Okay, you can also think 1 plus 5 is 6. I have x times a negative 3x. First off, there's nothing to multiply with that coefficient or number. So it stays at minus 3. Now, I have an x, 1 out here, and I have 1 inside. So if I combine them, it becomes 2. Okay, and then I have an x times a negative 2. That's just a negative 2x. Okay, first off, it is in standard form because I go from the highest exponent down to the lowest, and I cannot combine anything because they're all different exponents. Okay, going here to this last one for distribution. There's a negative 2x squared out in front. That is what I need to take and multiply into every term inside that parentheses. In this case, there's 4 terms inside the parentheses. So, negative 2x squared times 3x. Negative 2 times 3 is a negative 6. Now, I have 2 x's out. There's 1 inside, so that's a total of 3 x's. So, it's x cubed. Negative 2 times a negative 5 is a positive 10. I have 2 outside. I have 3 inside. That is power of 5. Okay, negative 2 times, remember, if there's nothing in front, there's really a positive 1. Okay, negative 2 times a positive 1 is negative 2. I have 2 outside and 2 inside, so it's power of 4. Okay, and then I say negative 2 times negative 2 is a positive 4. I have 2 outside and none inside, so I have 2 total. Now, this one we have to go a step further because I need to rewrite this in standard form. It has to go from the highest exponent down to the lowest. So the final answer really of this one would be 10x to the power of 5 minus 2x to the power of 4 minus 6x to the power of 3 plus 4x squared. Okay, so when you're working with these polynomials, make sure your final answer always goes from highest exponent down to lowest. Okay, so now the last part that we're getting into is FOIL. So first off, you probably learned that FOIL is an acronym, and it means that you're going to multiply the first terms, then you're going to multiply the outer, the inner, and then the last terms. Okay, there's your F, your O, your I, and your L. Okay, that's fine if you want to look at it that way and remember it. Okay, but I always like to say FOIL just stands for you're going to have multiple distributions that you're going to have to worry about, which we'll look about when I get to these examples. So, when do we use FOIL? So, first off, we use FOIL for multiplying. Okay, now, specifically, what are we multiplying? We are multiplying binomial, which, a refresher from the front of our notes, a binomial is 2 terms. We are multiplying a binomial or higher, so that means more terms, by another binomial or higher. Okay, these examples on number 3, A, B, C, and D are all FOIL problems. Okay, here on A, we're taking a 2-term by a 2-term, so binomial by a binomial. Here on, I guess if we go down here to C, we're taking a binomial times a 3-term, which is a trinomial. B, it's again a binomial times a binomial. And here on D, it's a binomial by a trinomial. Okay, I could multiply a trinomial by a trinomial and still use FOIL. So I can. Instead of really thinking about first, outer, inner, last, for FOIL, I like to say it's a double distribution problem. You're going to take your first parentheses, and each term in those parentheses, you're going to multiply it by everything in that second parentheses. So I'm going to take this 3x, and I'm going to multiply it to everything here in my second parentheses, the 6x and the 1. Okay, now, this is also the first in the outer step. I'm taking the first two things in the parentheses and multiplying them, and I'm taking the two outside pieces, or the outer pieces, and multiplying them. 3x times 6x. 3 times 6 is 18. X times x. You have one x, and you have another x, so that's x squared. 3x times 1 is a positive 3x. Anything times 1 is in itself. So now, you're going to take the second thing inside the parentheses and multiply it by everything in the other parentheses. Okay, your inners are your two things inside, and then your last are your last things in your parentheses. You're doing the same thing as FOIL. I just sometimes think about it as calling it double distribute. Negative 5 times 6x. Negative 5 times 6 is a negative 30. We have the x. Negative 5 times 1 is a negative 5. Now, the final step here when you have these problems, you're going to have some that can be combined, and you may have to rewrite. So, first off, 18x squared would be my first thing because it's the highest exponent. Now, when I get to my terms with x's, I have two of them. I need to combine them. I have a 3x and a negative 30x. That makes a negative 27x. And then I can attach my constant negative 5 at the end. Okay, now, if I go down here to B, okay, again, I'm going to take the first thing, the 2x squared, and multiply it to everything in that second parentheses. That's going to cover my first and my outer step. 2x squared times 3x. 2 times 3 is 6. X squared and an x, so you have two x's with another x, that's x to the power of 3. 2x squared and a negative 4, that makes it a negative 8x squared. Okay, then I have a negative 9 and a 3x. Okay, because I'm going to take, remember, that second term in that first parentheses and multiply it to everything in the second one. That's my inner and my last. Negative 9 times 3x is negative 27x. Negative 9 times a negative 4 is a positive 36. Okay, I went from highest exponent down to lowest, and I can't combine anything, so that's my final answer. I can't do anything more. Okay, if I go up here to C, okay, take the first thing and multiply it by everything in that second parentheses. So I'm going to take an x times an x squared to give me x to the power 3, or x cubed. I'm going to take an x times a positive 3x, so it would be positive 3x squared. X times a negative 7 is negative 7x. Now, sometimes when you get your multiplying ones where you're multiplying a binomial by a trinomial, sometimes I like to stack my answers. So if I find something that has the same variable and exponent, I will put them underneath each other so it's easier to combine like terms for our final step. Okay, so now take the 8, multiply it by everything on the other parentheses. Okay, and 8 times an x squared is 8x squared. Now, I'm going to write that underneath the 3x squared because I'm going to have to combine them. 8 times 3x is a positive 24x. And again, I'm going to write that under that negative 7x because those are like terms. I'm going to have to combine them. And then I have an 8 times a negative 7. That's a negative 56. It goes off by itself. Nothing to combine with it. So now, final answer. X cubed, a 3x squared, and an 8x squared becomes 11x squared. Negative 7x and a positive 24 becomes a positive 17x minus 56. I don't need to switch the order because it's already in order from highest exponent to lowest. I've already combined. There's my final answer. Okay, now when I get here to this last one, okay, x squared, I'm going to take and I'm going to multiply it to everything in the second parentheses. X times 5x to the fourth, or x squared, sorry, times 5x to the fourth would be 5x to the power 6, 2 plus 4. X squared times a negative 2x squared is negative 2x to the power 4, because 2 plus 2. X squared times 11 is a positive 11x squared. Okay, now I'm going to do the same thing with 1, just because of my visual looks like. I'm going to put it above, but it may look a little bit close. But there, I'm going to do it. Okay, negative 1 times 5x to the fourth would be negative 5x to the fourth. I'm going to put it underneath that negative 2x to the fourth because they have the same variable and exponent. Those are like terms. Negative 1 times negative 2x squared is a positive 2x squared. And again, I'm putting it under what is the same, so easier to combine. Negative 1 times 11 is negative 11. So now, combining my terms, nothing with a 5x to the 6, so it comes down. Negative 2x to the fourth and negative 5x to the fourth make it negative 7x to the fourth. 11x squared and 2x squared make it 13x squared. And then minus 11. It's from highest exponent down to lowest. I can't combine anything else. There's my final answer. Okay, so this should all be review of stuff you probably remember from Algebra 1. If not, it's okay. We went through it. You're going to see this be used here throughout the rest of your time in geometry. You're going to see it in Algebra 2. So if you have any questions, please reach out to me. Reach out to your classmates for support. Okay, we're all in this journey together to give success to everyone, to help each other out. We're not in this alone. Okay, see you next time when we continue further with this unit.